In this video, we are going to look at reflecting exponential graphs. First about the x-axis and then about the y-axis. So, in this first example, it says consider f of x equal to 2 to the x minus 1 minus 3. Give the equation of g of x, f of x reflected about the x-axis. Now, remember that when we reflect about the x-axis, the y-coordinates change sign. So if we were to look at the rule for individual points, the coordinates xy would go to x keeps its sign, but y changes sign. So if y is negative, it'll go to positive and vice versa. Okay, so also remember that a reflection about the x-axis causes a mirror image about that x-axis. So I'm just going to highlight the x-axis here for us. Okay, so if we were to fold along this line, that's where our reflection would happen. Okay, so drawing this reflection, the first thing that's going to change is our asymptote is going to go from -3 to +3. So the asymptote is also reflected about the x-axis, and it changes because the y-coordinates change. Okay, now reflecting individual points, I have the coordinates 4, 5. Those coordinates will go to -4, 5. Then I have the x-intercept, that will remain unchanged. And then I have the coordinates 1, -2, and those will go to 1, +2. And that allows me to be able to draw the graph. Okay, so do you see the mirror image about the x-axis there, which is the purple line in this case? Okay, so what we notice on the graph is that the asymptote has been reflected, the x-intercept remains unchanged, and we have that mirror image. Now coming to the equation, what happens in the equation, so it said label it g of x. In the equation, remember that with the reflection, the y-coordinates change. So we are going to go from a positive y value to a negative y value, which is f of x. So I'm going to substitute f of x into brackets here. So I have 2 to the x minus 1 minus 3, and that is not in standard form, so I have to multiply out the negative to the brackets. So distribute the negative, sorry. So that gives me -2 to the x minus 1 plus 3, which is acceptable standard form. So that is our final equation. Looking at a reflection about the y-axis, we have the same function, the same graph, the same question, except that now we are required to reflect it about the y-axis. Now remember, when we reflect about the y-axis, the x-coordinates change sign. And the rule for individual points is that if we start with x, y, that changes to -x, y. So it's only the sign of x that has changed. Okay, now we are reflecting about the y-axis. So I'm just going to highlight our y-axis, and in our reflection, we cause a symmetry about that y-axis. So drawing the graph, our asymptote remains unchanged. The asymptote is already symmetrical about the y-axis, okay? But if we look at individual points, the coordinates 4, 5 will go to -4, 5. The coordinates 3, 1 will go to -3, 1. My y-intercept will remain unchanged, and that allows me to draw the graph. Okay, so summarizing what happens in the graph, your asymptote is unchanged, your coordinates, only the x values change sign, and your y-intercept is also unchanged. looking at the equation now. So it says consider f of x equals 2 to the x minus 1 minus 3. Give the equation of g of x, which is f of x reflected about the y-axis. Now remember, x coordinates change sign in this reflection. So instead of f at x, we will have f at negative x, which means that wherever we have an x, we're going to replace it with negative x. So that gives us 2 to the negative x minus 1 minus 3. Now that is not in standard form, okay, because we have a coefficient to x. So that means we need to factorize out that coefficient to x, and we are then left with negative the bracket x plus 1 minus 3, okay? Still not standard form. So we need to apply this negative to the base. Now remember, if we have a base with a negative exponent, Now remember, if we have a base with a negative exponent, we can rewrite that as 1 over 2 to the positive exponent, okay, which is what we are going to do here. So our base is going to change to a fraction. So instead of 2 to the negative 1, we have a half. Remember that if our base is a fraction, we must write it in brackets, and then we are left with x plus 1 in the exponent, and we don't have to write that in brackets. Okay, minus 3, and then what we have there is in standard form and thus acceptable.